So I want to share a couple of examples of graphing a piecewise function with you. And there are a couple of different ways of dealing with them. So I'm going to try to talk you through kind of the two main ways that I know of to deal with graphing piecewise functions. So the first way is to truly just graph each function and then go back and erase the parts that you have to get rid of. So let me show you what I mean by that. So if we graph this first function, this negative 2x plus 1, I'm just going to graph that whole graph. So I'm going to start up 1, and I'm going to graph my slope of negative 2, so up 2 over 1, up 2 over 1, up 2, I guess I should be more specific, I'm going up 2 and left 1. Or I could go down 2 and right 1, down 2 and right 1. So here's my line. I'm not good at drawing straight lines. I'll do the best that I can for that. All right, so there's that line. But now we need to go back and actually do some erasing. So we need to look at what this constraint is telling us. And it's saying that we want values where x is equal to negative 1 and lower than that. So really, I'm going to darken in. I'm going to go back over and darken in and recolor over that part. So if you can see, I'm making that point darker, and I'm gonna draw this a little bit darker. What it means is that we do not want to include this part of the graph right there. So now we do have to consider that end point, this specific point, and because of that less than or equal to sign, we know that should be a solid point there. Okay, so then we want to graph this second line, and we're going to graph the whole thing, but then we'll go back and erase the parts that we need to get rid of. So I'm going to just focus on graphing this line. I'm going to start at negative 2 on the y-axis, and I'm going to go up 1, right 3, up 1, right 3, up 1, right 3, or down 1, left 3, down 1, left 3, and so on. And I'm going to draw my line as straight as I can. And then I need to think about and consider what this constraint is telling me. So it's saying we want x values that are greater than negative 1. So that's from this point right here and all the way over in this direction. So what that means is that we need to erase this all the way up to there. And because this was, let's go back and think about this, because this is a greater than sign, we know, let me clean this up a little bit. Because that's a greater than sign, we know that this needs to be an open circle. All right, so that's one way, and I think that's the way that most people prefer to do the graphs, because it helps you see the entire graph and then get rid of the parts that you need to graph. Another option, it's not going to let me erase now. Uh-oh. Another option is to use points. So let me see if I'm going to be able to write here. Yeah, okay. I paused, and I was afraid I was going to lose some functionality here. So, all right, here's the other option. The other option is to really consider each of these equations and come up with coordinate points to plot. So this is telling us we want to consider the x value of negative 1. And if we plug negative 1 into this equation, then we would be solving negative 2 times negative 1 plus 1. So we get 3. And we can plug in some other x values that are less than, that's this part of the graph, less than negative 1. So let's plug in negative 2 and negative 3 as an example. So if we plug in and do negative 2 times negative 2 plus 1, we find that we get 5. And if we plug in negative 2 times negative 3 plus 1, we get 7. So we would graph those points. So negative 1, 3, negative 2, 5, and I'm not being very careful and methodical about those points because I'm kind of using this line as my guide, because it should make sense to you that we're going to get the exact same graph. Now we do similar process. Now at negative 1, we want to plug in negative 1, but we want whatever that point value is, we want it to be an open circle. So if we plug in negative 1 into this other graph of 1/3 times negative 1 minus 2, so we get as our answer negative 2 and 1/3. And that's where our open circle is. So let's plug in some other points. Let's plug in x is 0, and let's plug in, to make this math easier, let's plug in x is 3. So if we plug in 0, we know we're going to have negative 2. If we plug in 3, we're doing 1/3 of 3 and then minus 2. So we get 1 minus 2, which is negative 1. And we graph those particular points, and then we can draw and finish and continue drawing the line. So that's how we, two different ways in which to draw or think about how we can draw those graphs. Let's look at one that's a little bit more complicated, because this one has a parabola included. So I'm going to just use the second technique for this one, just because I want you to see some of the points. So for this particular graph, I'm going to look at that x is less than or equal to 2 for x squared. So I'm going to plug in negative 1 and 0 and 2. I'm going to plug into this top equation. So if I plug in negative 1 and I square it, I get 1. If I plug in 0, I get 0. And if I plug in 2 and I square that, I know I get 4. So at 2, 1, 2, 3, 4, I can use, the reason why I'm wanting to look at these points is that it will be easier to actually draw this way. I can use symmetry to help me draw this graph so that it looks somewhat like a parabola. So we know this is going to continue in that direction, and because this is less than or equal to, I know I want to include a closed circle there at that particular point. Now I want to go ahead and change colors and think about the second part of this graph. So I know I'm not going to include the point, but I'm going to draw an open circle wherever this 2 value would be. So I want to plug in 2, and how about if I plug in, I don't know, about 5. I don't have to plug in as many of those. We just need 2 points, right, to create this line. So if we plug in 2 into this equation, we're going to get the opposite of 2, or negative 2 plus 5, so we get 3. And if we plug in 5 into this, we're going to have the opposite of 5, or negative 5 plus 5, so we get 0. So at positive 2, I want to graph 1, 2, 3, an open circle. And then the other point that I want to include, 1, 2, 3, 4, 5, is right here. Boom, there's my line. Done. Nice, huh?